Base lengths of isosceles trapezoid ABCD, so A to B, C, D, shown below are in centimeters, and E is on AB, okay? What is the ratio of ABCD to the area of AED? So we have the trapezoid to this triangle AED, and we want to know the ratio of the triangle to the trapezoid. Okay, so the area of a triangle is base times height divided by 2. The area of a trapezoid is base 1 plus base 2 divided by 2 times height. Alternately, you could also divide this into a triangle. So you have two triangles you could calculate the area for, and the rectangle. So what I'm going to use the formula because it's a little bit easier. So 40 base 1 and 60 base 2. So 40 plus 60 divided by 2. And we don't know what the height is. Okay, so, but because we're using a ratio in which the height is going to be the same for both, we can plug in a number. So 40 plus 60 is 100 divided by 2. Let me add a little space here. So 40 plus 60 is 100 divided by 2 times 2, right? That's our height, and that's going to cancel. That means our ratio of the trapezoid is 100. And then let's do the same thing for the triangle. Well, how do we figure out our base? Well, 60 minus 40 is 20 between these two sides. Divide that in half. Half for this side is 10. Half for this side is 10. So our base is 10. We plugged in a height of 2, so 10 times 2 divided by 2, and that means it's 10. So the area of the trapezoid is 100. The area of the triangle is 10, and that reduces 10 to 1. So your answer is D. And this would have worked no matter what we chose for the height. We could have chosen 2. You could have actually chosen 1. I never choose 1 or 0 if you're plugging in numbers, because 1s and 0s do weird things. And so 2, 5, 10, if you go into 1, it's a little closer maybe to the actual ratio of the height. You might have gotten like a 15 maybe. Probably would have been close. So anyway, answer is D. Real value of x satisfies the equation log 5, 25 squared equals 2x. Okay, log base 5. So this is logarithms, and I usually remember logarithms by log 2 to the third equals 8, so 2 to the third is 8. Log base 2, 8 equals 3, so 2 to the third equals 8. I just kind of remember that pattern. It makes it easy, especially just for ACT. So in this one, you'd have 5 to the 2x equals 25 squared. So 25 squared is 625. So 5 to the 2x, right, equals 625. So to what power, when we raise 5, does it equal 625? So I'm just going to plug in these numbers for a minute. So 5 to the 4th, does that equal 625? And it does. And to me, that's the fastest way to do this question instead of actually solving for x. So F is your answer. In the figure below, points E, F, G, H, so E, F, G, H, are on the sides of square ABCD, so ABCD, okay. Arc EH has a center at A, okay, so that's the center at A. EF at B, so these are all the same, right? They're all quarter circles. What is the area in square feet of the shaded region? Oh, all the arcs have a radius of 3. So the center out is a radius of 3. So that's 3. So that means also from here to here is 3. So our entire side is 6. So area in square feet of the shaded region. So let's get the area of the square. So 6 is one side times 6 of the other. That equals 36. So the whole portion is 36. And we then want to subtract the portions of each of these quarter circles, which makes one full circle. And the formula for the area of a circle is pi r squared. And we know this is pi 3 squared, or 9 pi. So to get the area of the shaded region, we take the entire area, 36, minus the circle, 9 pi, which gives us our answer as E. For all real values of x, such that 0 is less than x, is less than pi divided by 2, so that's 90 degrees. Right, so if we had a circle, pi over 2 is right there. Which of the following expressions is not equal to tangent of x? Okay, so we're going to have SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then we have the reciprocals. Cosecant, hypotenuse over opposite. Secant, hypotenuse over adjacent. Cotangent, adjacent over opposite. So we want to see when we put these together, we're looking for opposite over adjacent. Which one does not give us opposite over adjacent? So 1 over cotangent x is 1 over cotangent x is adjacent over opposite. Well, then we would do the reciprocal of that to multiply the top and bottom by opposite over adjacent. Gets rid of this, top opposite over adjacent, we get opposite over adjacent. So F is equivalent to tangent. So now let's do choice G. So secant of x, secant, hypotenuse over adjacent, cosecant over hypotenuse over opposite, opposite times hypotenuse, opposite times hypotenuse, right? So these all end up canceling and we have opposite over adjacent. So that one is equivalent as well. So then choice H, sine over cosine. So sine, opposite over hypotenuse. Cosine is adjacent over hypotenuse. So multiply hypotenuse adjacent again. And so these cancel, these all cancel. So we have opposite over adjacent again. So that is also equivalent to tangent of x. So cosine of x, so cosine is going to be adjacent over hypotenuse. Cosecant of x is hypotenuse over opposite. Okay, so now we have adjacent over opposite, which is not tangent, because tangent is opposite over adjacent, so it has to be J. And just for the sake of showing, let's do this last one. Sine times cosine, sine times secant. Sine, opposite over hypotenuse. Secant, hypotenuse over adjacent. And those cancel, and we get opposite over adjacent, which is also tangent. So that's just a time-consuming problem, unless you really know your sine, cosine, secant really well and can put the algebra together quickly. So church has a sale price of $30.40, which is 20% off the original price. How much less than the original price is the sale price? So we know we paid $30.40. And we know we're looking for the original price. And the original price is, or what we paid, is 20% off the original price. I always like to do percent as fractions so you don't make a mistake, because if you said 2%, that would be 0.02 and not 0.2. And I know ACT sometimes does things like that to mess with you. All right, so $30.40 equals 0.02 0.8x, because x minus 0.2 is 0.8x, or 1x minus 0.2. And then, so $30.40 divided by 0.8 gives us x equals $38. So then we have $38 minus $30.40 equals $7.60, which is how much less than the original was the sale price. So D. The clock shown below has a minute hand that is 4 inches long, okay, 4-inch long minute hand, and the center of the clock face is 10 inches above the bottom surface of the clock. Okay, so from here down to here is 10 inches. Let X be the time in minutes after the clock strikes 3, okay, striking 3. Let Y be the height in inches. The end of the minute hand is above the surface of the clock. So from here all the way to here is Y. So that's actually going to be 4 inches plus 10 inches. So it's 14 inches above the base of the clock. So 10 inches, 4 inches. One of the following graphs in the standard coordinate plane shows the height as a function of time. Okay, so go down to the graphs. So we're starting at 14 inches above. So this one can't be it because that's 10. That's 10. This is 14. K is 12. And H is 10. So the only one that actually works when I had to look at the graph is G. And as the clock's going to go down, minute hand down and back up over the period of an hour. So it starts at 12. In case you want to see that, right? 12, 6. And this is its height, and it goes down and then back up. So down and then back up. So G. Following information to answer questions 47 to 49. It's a really bad start. Let's do that again. Okay, a regular isosahedron is a solid that has 20 congruent faces. Okay, so faces 20, each of which is an equilateral triangle. So we see it down here. Each vertex, so the vertex is shared by 5 faces. A specialty die used in a game board. Okay, 10 faces, the die are visible. Got the basics of it. Got a table that has the number of dots on the number of faces. How many edges does the specialty die have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides showing on this 20-sided die. That means we see half of it. So we could just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 on the inside. That means it's going to be 12 exactly matching ones on the other side. So 12 plus 12. And then, so it's 24, 25, 26, 27, 28, 29, 30 on the outside. So that's one method to do it, is simply counting the shapes. If we wanted to do the formula, I'm not even sure if what the formula this is exactly, but we would have to do the number of sides or triangles, 20, times the number of sides divided by the shared side. Each triangle shares a side. That would be 60 divided by 2, which is also 30. And I put these examples down here to kind of show how this works. So if you had a 4-sided shape, okay, so it's 4 on top, 1, 2, 3, 4. I broke them out here. And 4 on the bottom, 1, 2, 3, 4. That would be 8 times 3, number of sides in a triangle, divided by 2, and you have 12 shared sides. Same thing goes for 3. 6 triangles, 6 times 3, 18 divided by 2 is 9. So 6 shared edges. So this formula works because it's just breaking down how many they have. So your answer is D, 30. What is the area in square centimeters of one face of the specialty die given that the length of each of its edges is 2 centimeters. Okay, so these are all 2 centimeters each edge. So area of triangle is base times height divided by 2. Well, we know our base is 2. We know we're going to divide by 2. But what is our height? So anytime you have an equilateral triangle divided in half, you get a 30, 60, 90 triangle. So 30, 60, 90. And that means that half of this 30, 60, 90 triangle is 1, and the other half is 1. We'll divide the bases. And the sides are x, so x, 1, 2x, and then x root 3, which is here. So if this is 1, that makes this 1 root 3, or root 3. So now we know our height is root 3. So base times height divided by 2, these cancel, so our height is root 3, or our area is root 3, G. When the specialty die is rolled, only one face will land on top. Each of its faces has the same probability of landing on top. Which of the following values is closest to the probability that the face that lands on top will have 3 dots? So 3 dots right here. 3 of the faces have 3 dots. So probability is what you want over what you have. And we want 3 out of 20 faces. So 3 divided by 20 is 0.15, or C. Tom is in Miss Zhu's class to choose 4 students from her class of 24 students to answer questions. Miss Zhu will put 24 cards, each with a name of a different student from her class on it, in a box. She will randomly draw 4 cards from the box without replacing any of them, so she's not going to put their names back in. What is the probability that Tom's card will not be drawn? Okay, so the first draw, she has 24 cards to choose from. Tom doesn't want his card to be drawn, so he's got a 23 out of a 24 chance not to be drawn. The next draw, there's only 23 cards in there, and he's got 22 out of 23 chance of being drawn. And there's only 22 cards in there. He's got a 21% chance, or 21 out of 22 of not being drawn. Then there's 21 cards, and he's got a 20 out of 21 chance of not being drawn. So these cancel because we're multiplying across. So now we have 20 out of 24, and 20 out of 24 reduces to 5 out of 6, or J.